Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video we're going to talk about production and growth in an economy, including an introduction to the Cobb-Douglas production function. We define productivity as the quantity of goods and services produced from each unit of labor input. This directly translates to the standard of living in a country. When each worker is able to produce more, the GDP per person increases. Since total production must also equal total income, productivity growth leads to income growth. The standard of living, as measured by GDP per person, varies greatly from country to country. The table on the screen shows the GDP per person, adjusted for inflation, in a variety of different countries from a period of about 1900 to 2017. Looking just at the historical numbers first, we can see that the United States and the United Kingdom were by far the wealthiest countries. Countries like Bangladesh and China rank near the bottom. Over time, the GDP per person in all of these countries grew, but the growth rate differed greatly. The United Kingdom started out as the wealthiest country on the list and ended up as one of the wealthier, but not the top, and had the lowest growth rate of 1.43%. On the other hand, China had the highest growth rate per year of 2.64%, and grew from one of the poorest countries to certainly not the top, but one of the middle-ranked countries in terms of GDP per person. Other countries like Pakistan and Bangladesh started out as some of the poorer countries and had growth rates not much higher than the UK and have remained among the poorest countries on the list. We'll keep some of these figures in mind as we move forward and talk about some of the reasons why some countries grew faster than others. Broadly speaking, productivity is determined by the amount of productive resources that are available within a country. Workers cannot produce much without other complementary resources. Generally, the more of those that are available per worker, the more productive each worker is going to be. The first factor to think about is physical capital. Physical capital is the stock of equipment and structures used in the production of goods and services. These can range from simple handheld tools like a hammer, to a factory, to sophisticated electronic equipment. The more physical equipment there is, the more effective each worker can be. In economics, when we refer to just capital, this is usually what we mean. Next, we have human capital. Human capital is the knowledge and skills that workers acquire through education, training, and experience. Even if we have lots of workers and lots of physical capital, we can't do much with those without knowledge of how to use them. An economy with a more educated and highly skilled workforce will be more productive. Next, we have natural resources. Natural resources are productive resources provided by nature. This can include the land itself, rivers, and mineral deposits found underground. Some natural resources, like trees, are renewable, but others, like oil or minerals, are not. Throughout history, the availability of natural resources has been a huge factor in determining the standard of living of a country. Countries like Brunei and the United Arab Emirates have relatively small populations, but huge reserves of oil. This has led to both of those countries ranking among the highest in the world in GDP per person. However, countries with limited natural resources can overcome that deficiency by investing in physical and human capital. Japan is a great example of a country with limited natural resources but a highly educated workforce with a highly developed stock of physical capital. The final factor to think about is technological knowledge. This is a society's understanding of the best ways to produce goods and services. In economics, we define technology as the way that inputs are turned into outputs. This does not necessarily imply high tech in the colloquial sense. For example, the technology to produce coconut milk could be simply hitting a coconut with a rock. An improvement in technology may simply be a better way of doing things, like hitting the coconut with a hammer. An improvement in technology can enable a smaller amount of workers to produce the same amount of output as before. One worker with a hammer might be able to accomplish what two workers could do with a rock. This is the very definition of an increase in productivity. We're now going to put all of these factors together into an economy's production function. The production function gives the relationship between the quantities of inputs and the quantities of outputs. We've previously used the concept of the production function to describe the relationship between inputs and outputs for an individual firm, but we can do the same thing for an entire economy. In reality, a country's production function involves all kinds of different things, including the things we talked about: physical capital, human capital, workers, and technology, and potentially other things as well. For simplicity, we are going to look at production functions with just two inputs, but the lessons that we learn here can certainly be applied to more complex production functions. Just like we have before, we're going to use the variable y to represent the GDP of a country. We're going to use two inputs, capital and labor. K stands for capital, I think because C is already taken as cost, and L stands for labor. Here, L will be the total number of workers available in the economy. We write out a production function as y equals A times F of K and L. F is a function of K and L, and A is what we call total factor productivity. TFP for short. If we know our capital and labor and plug those into the function, we then multiply the whole thing by the TFP to get our GDP. The higher the TFP, the higher the production will be for any given amount of capital and labor. We generally think about TFP as representing the level of technology in an economy. The better the technology, the higher the output. One of the most common functional forms for the production function is called the Cobb-Douglas production function. The Cobb-Douglas function, which is named for two American economists, is very popular for its convenient mathematical properties. If you go on and take more economics classes, you're almost certain to see it somewhere. The Cobb-Douglas function will be y equals a k to the alpha, L to the beta. Alpha and beta are constants. They're just numbers that describe the relative importance of capital and labor to the overall production. Note we can also use Cobb-Douglas functions to describe the production of an individual firm. Consider an example where we have a total factor productivity of 10, alpha equals 1/2, and beta equals 1/2. This gives us the production function y equals 10 k to the 1/2, L to the 1/2. We can now plug in any values of K and L and figure out what the total GDP in the economy is going to be. For example, suppose that our economy has 4 units of capital and 9 units of labor. To figure out the GDP, we just take 10 times 4 to the 1/2 times 9 to the 1/2. This gives us 10 times 4 to the 1/2 is 2. It's the square root. 9 to the 1/2 is 3. And that's going to give us a total GDP of 60. Now that we've established a production function, we can use this to describe a country's standard of living. We are going to use the measure of GDP per worker to think about the standard of living. That's just going to be y divided by L. In our example, remember that y equals 10 k to the 1/2, L to the 1/2. To figure out the GDP per worker, we divide both sides by L. Remember that L is actually L to the 1. We're now going to apply our rules for exponents. When we divide terms with the same base but different exponents, we subtract the exponents. And so what we get here is 10 k to the 1/2. Now we have L to the 1/2 divided by L to the 1, and so we take 1/2 minus 1 and get L to the negative 1/2. When we have negative exponents, we can move those terms to the other side of the fraction. And so L to the negative 1/2 is the same as dividing by L to the positive 1/2. I'm now going to pull the 1/2 power out, and so we get 10 times k over L to the 1/2. And this just cleans things up a little bit. In our example, remember that we had 4 units of capital and 9 units of labor. Here we have k over L equals 4/9. Remember that capital per worker is one of our measures of productivity. Y over L will be 10 times 4/9 to the 1/2, which is going to be 10 times 2/3, because we need to apply the 1/2 power to both the 4 and the 9. Can't forget to do that. And that's going to be approximately 6.67. These numbers by themselves don't mean a lot, and so we need to compare what happens when K over L goes up. What's going to happen to Y over L? The bigger K over L is, the bigger K over L to the 1/2 is going to be, and so as capital per worker increases, GDP per worker also increases. Likewise, if TFP were to increase, so our 10 were to go up, then GDP per worker would also go up. This tells us that if capital per worker increases or technology improves, the standard of living will rise within a country. I've used the computer to draw a graph of the relationship between capital per worker and GDP per worker. This is simply the function y over L equals 10 times K over L to the 1/2. We can see from this that y over L does increase when K over L increases, but we can see that it increases at a decreasing rate. Consider a country with a relatively low capital per worker, let's say 1. If they increase the capital per worker by 1, we can see that the gain in GDP per worker here. Now consider a country that already has a lot of capital per worker, let's say 4. If they increase their capital per worker by the same amount, we can also look at the GDP per worker that they gain, and we can see that it is substantially smaller than the GDP per worker gain from the country that started out with a lot less. This means that if we hold the amount of workers constant, there are diminishing marginal returns to increasing capital. A country with relatively little capital will experience larger gains from increasing capital than a country that already has a lot of capital. We saw some examples of this in the chart we looked at the beginning of the video. 100 years ago, China had a relatively low capital per worker, whereas the United Kingdom had a relatively large capital per worker. Over the last 100 years, China has built up a huge amount of capital and has gained significantly in GDP per worker. Overall, what we see here is a catch-up effect where poor countries are able to grow faster than already wealthy countries. We've established that increasing productivity increases the standard of living in a country, so let's talk about some of the factors that can result in economic growth. Remember that we define investment as expenditure on physical capital, so increasing investment can increase the standard of living in the future. However, remember that expenditure on investment is expenditure that is not happening for current consumption. So increasing the standard of living in the future requires sacrificing some consumption today. Investment does not only have to come from within a country itself. Foreign investment can also increase a country's productivity. If we think about a US auto manufacturer building a plant in Mexico, remember that that is capital that is now located within Mexico, and production at that factory is contributing to Mexico's GDP. More developed countries investing in less developed countries also facilitates the flow of technology into those developing countries. With this in mind, the World Bank and International Monetary Fund facilitate loans from wealthy countries into developing ones. Those developing countries can use these loans to invest in physical and human capital, which we'll talk about in a minute. And because of the catch-up effect, investment in those countries has more of an impact than had that same level of investment happened in an already developed country. We can think of education as investment in human capital. As we've discussed before, education has a positive externality. It does not only improve the earning potential for the person who is getting educated themselves, but educated people also improve the society they live in. One way they can do that is by becoming more productive. Health and nutrition is another important component of human capital and constitutes a major difference in the productivity between the developed and developing world. Nutrition is something we often take for granted in a developed country, but in many parts of the world it remains a problem. Lagging education and nutrition remain an important reason why a lot of countries in sub-Saharan Africa, for example, experience a lower standard of living. It's important to note that the legacy of colonization hangs over much of Africa. The European powers aimed mostly to exploit the population and the natural resources of those countries and failed to invest in their people and local institutions. Decades after colonization ended, Africa continues to lag behind for many of these reasons. Next, growth in technology is one of the most important factors for improvements in the standard of living. If we compare the standard of living today to that of 200 years ago, we are vastly better off in a variety of different ways. 200 years ago is a relatively small amount of time compared to the whole of human history, yet the Industrial Revolution led to a vast increase in productivity and therefore to our standard of living. While innovation is often privately motivated, the positive externality associated with it means that society benefits more than the individual does. And so the private incentives to innovate are not sufficient. For this reason, the government has an important role in promoting innovation as well as disseminating it throughout society. The last thing I want to talk about here is population growth. We've so far discussed economic well-being in terms of GDP per person or GDP per worker. If we consider one of these measures, like Y over L, as population grows, L is going up. Of course, as population grows, GDP also grows. But if the growth of GDP does not keep pace with the growth in population, then people are actually going to be worse off overall. For the standard of living to continue to grow as population grows, the other factors of production need to be growing as well. As we've discussed before, this includes things like technology, physical capital, and education. In the late 18th century, the early economist Thomas Malthus warned that as population across the world continues to grow, the world's resources would inevitably be stretched to their limit and the entire world would be plunged into poverty. While that may have been true if technology had remained at the level that it was in Malthus's day, he could not have predicted the vast growth in technology over the last 200 years. In particular, agricultural productivity has grown to the extent that we are still able to feed the population of the world, despite the significant increases in population. This has been an introduction to production and growth in an economy. If you have any questions, feel free to let me know. Thanks for watching.